Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph an inequality. Now, graphing an inequality is going to be different than graphing an equation, because when we solve for an equation, we have like x equals 5 or x equals 2. Well, that just is one value. So when we're graphing inequalities, for instance, x is greater than 5, that represents multiple different solutions, right? 6 is greater than 5, 10 is greater than 5, and 100 is greater than 5. So we got to be able to graph something that's going to represent all of the solutions, rather than just one little point saying, hey, here's the x equals 5. That's the one solution. Now we got to represent a whole list of solutions. So we're going to use a number line. Now, I chose to use a blank number line because a lot of students have trouble when you have to graph something and they have a blank number line. A lot of times it's easier when, on your homework or on a test when a number line is already filled out. So I want to kind of give you a tip on how I like to graph when I have a blank number line. And the best thing I like to do is, regardless of what the solution is, I look at my value and I say that's going to be in the middle of my number line. Rather than always picking 0, which is pretty common like on a textbook and so forth, I'm going to choose 5. Then for ticks to the right, those are going to be increasing, 7, 8, 9, 10. And then going to the left is going to be decreasing. You can see 0 here is still represented. Now remember, the arrows, you got to make sure you include the arrows. That's going to tell you that these numbers are going to continue increasing, and these numbers are going to continue decreasing into the negative number system. Now we have to be able to identify how to graph it. So the main important thing is we're going to want to make a circle at our value. And we're just going to leave that circle open. Now what we need to do is go ahead and use our kind of test point to be able to verify. Is 5 a solution to x is greater than 5? And what you simply do is plug in 5. I'd like to use a different color here. You plug in 5 is greater than 5. Is 5 greater than 5? No, that is false. So therefore, since it's false, we're still going to keep the circle there, but it's going to be what we called an open circle. All right? It's going to be an open circle. So therefore, we're going to leave it open there. Then we kind of choose some test points to the right and a test point to the left. So let's do 9 is greater than 5. And you see that 9 is greater than 5, which is a point here that is true. So if it's true on one side, that means all the points on the right-hand side are also going to be true. And on the contrary, you can choose a point to the left. Let's choose 0. That is false again. So therefore, it'd be no, you're not going to graph to the right. So therefore, to represent all these dots that would be true, all these points are going to be true, instead of putting dots for each one of those, we are just going to draw a line going to the right. And again, if you look at these numbers, all these numbers are greater than 5. And a lot of students already quickly come up to the idea that, oh, well, if the arrow is pointing to the right, let's go to the right. And let's go ahead and see if that makes sense for this problem. Here I have x is less than negative 2. So again, I'll start negative 2 here. Going to the right would be larger numbers, negative 1, 0, 1, and 2. To the left is going to be smaller, negative 3, negative 4, negative 5, negative 6, negative 7. Now, hopefully you understand that this is a greater than, this is a less than. So therefore, even if you plugged in negative 2 is less than negative 2, you see it's false. So I know I'm going to use an open circle. So anytime you have a less than or a greater than, it's always going to be an open circle. You don't even have to always use the test point anymore. Hopefully you can start maybe seeing, oh, there's a little bit of a pattern with that. Then, rather than even doing test points to the left and right, which is good when you first start learning how to do this, but once you kind of get the hang of it, you can see that, OK, well, this is going to the left. So let's choose all points that are going to the left. And then let's just go and verify. Is negative 7 less than negative 2? Yes. Is 2 less than negative 2? No, that's going to be greater than. So that these points will all be false. These points will all be true. Good. All right. So now let's go ahead and pick a point like this here. So here, my point is going to be 6. So I'll choose points to the right. And then I'll choose points to the left, or not choose points, but I'll label them. OK, now here's where a lot of students make their mistake. OK, now first thing, actually, let's talk about the greater than or equal to symbol. So now I'm going to make my open circle here. Now let's plug that in like the test point, like I told you to do before. And see, 6 is greater than or equal to 6. So we plug in 6 in for x. Is 6 greater than 6? No. But is 6 greater than or equal to 6? Yes. So since it's true, this is going to be what we call a close point. I think that's open. I'm not sure if I said close accidentally. That's an open point. This is a close point. Now, a lot of students do two problems like this, and they say, oh, if the arrow points to the right, you go to the right. If the arrow points to the left, you go to the left. So then they automatically say, well, the arrow's pointing to the right, so we're going to graph points to the right. However, let's read this. That is only true when x is on the left-hand side. Okay? So if you have like a kind of a question to this, I said using these test points is helpful, but not always, not always beneficial because it's a little bit extra time. However, if you use test points, you can always kind of like check your work. So for instance, you're thinking, let's graph to the right. So let's plug in some test points. Let's do 6 is greater than or equal to 11. And let's do 6 is greater than or equal to 1. Well, this is true. This is false. You're always going to graph to all the points that are true, not to where it's false. Case in point. So then why does that work then? Well, again, as I mentioned, this only works when x is on the left-hand side. So if we were to rewrite this problem, it would look like this. X is less than or equal to 6. So in reality, you can see here, all the points to the left are true. So I shade them. And again, these points are going to continue, so I include an extra arrow. A lot of students will forget to do that arrow. It's very, very important. Yes, I know the number line has arrows, but the solution points also needs to contain an arrow. All right, and the last example, another one students have a lot of trouble with is when we're dealing with fractions. And the reason why they're, fractions are decimals. Now remember, our number line here is based with integers, right? So I don't have an integer for negative 3.5 is not an integer. So what I'm going to do is I'm going to choose the closest integer to it. And let's just choose negative 3. So therefore, this would be negative 4. Oops. To the left is negative. Negative 4, negative 5, negative 6, negative 7, negative 8. This would be negative 2, negative 1, 0, 1, and 2. So remember, negative 3.5, that's going to be between negative 3 and negative 4. So it's going to be in between these two values. So I'm going to put my circle not at one of the tick marks, but in between them. And if you have a fraction, that's basically what you're doing. It's going to be in between some integers. So you just need to identify the integers that's going to be in between, and then plot your point. Now, this is a greater than or equal to. So remember, anytime it's greater than or equal to or less than or equal to, it's going to be closed. So we're going to fill this in. Then it says all the points that are greater than negative 3.5. Well, you could do test points, or you could just see, oh, the positive numbers are obviously greater than the negative. And you can also see the arrow points that way. So you're going to shade over to the right. So there you go, ladies and gentlemen. That is just a basic example, basic tutorial on how to graph inequalities. Thanks.